Okay, thanks for joining. Sorry for all that nonsense. Let me share my screen real quick. Over here is this. You guys see a slide at this point?
Yeah.
Okay, cool. Okay, so today we're going to talk
Oh
about
yeah.
BGP.
Um,
Against that. Okay, yeah, we're going to talk a little bit about BGP. I'm going to take you through the topology that I use, which is a simple topology, but I want it to represent multi vendors. So with that being said, I have Cisco, Juniper, and Arista, and all of them are virtual routers that are running in AWS. The next thing we're going to talk about after we see the topology is resource modules. So if you joined a couple of sessions ago, we went through access control list, and a big part of that was managing access list using resource modules. So in that same vein, we'll take a look at BGP, and we'll start from the viewpoint of how we can do similar management of automating through leveraging the resource modules, but we'll kind of take it to the next level with a additional layer of abstraction on top of the resource modules using the validated content for BGP. So this validated content is fairly new, so I'll take you through some of the capabilities, or at least the capabilities that I feel comfortable with at the moment. Being that it is new, there are some limitations in that it does provide a wrapper over the resource modules, but it sort of limits you in the sense of how you can push your configs. So in other words, you have to kind of comply with the whole structure that they set up for the validated content. And I still prefer a little bit more flexibility. So what I'm doing is I'm going to use the validated content to do a lot of the heavy lifting in terms of being able to go out to a brownfield environment, pull in the configuration data specific to BGP, convert it into configuration files, and organize it for me across my different types of devices that happen to be multi-vendor, which eliminates the need for me to go in and actually prepare a playbook that has the various modules that map back to the namespace for those collections. So a lot of times, if you were to do that manually, there's going to be some work to set up those configuration files, especially if you're working with a brownfield that you've never automated before. So I feel that the validated content for BGP does a really good job of that part of it. But then when we're ready to make a configuration addition or to change a configuration, then I'm still preferring using the resource modules directly. And I can kind of point out like some of the reasons why I'm sort of at that point right now. But at some point, as they add more features into the validated content for this particular use case, then it may work a little bit better. But I noticed that it does kind of limit me to some extent. So I'll show you that aspect of it. Another thing is we're not going to today, and especially since of due to time and everything, we don't have time to explore using the Git repository, the remote repository, and how we can make changes there by committing using the collection to commit our code. As we change, those configuration files, we're working in an what we call an EE. So in that context, it's really a container, right? So when we work in these environments, these EE environments, we're really working locally where the core Ansible engine is installed, which happens to be, on that execution environment directly, which means that if we want to push, a change that we've made into the repository, it's a bit different from the standpoint of like the AAP, where it's pretty easy to create a project, and then that project can point to a Git repository, and we're effectively just cloning down all of that, project data, which happens to be the playbooks and any other templates or config files. But in the reverse direction, when we push a configuration change directly from an EE, then that would allude to us needing to set up, additional credentials like tokens, depending on which Git repository we're using. In my case, I'm using GitLab, so I need a token. I need my username. I need email. There's some information that I need to package up front into a credential. And unfortunately, it's not like one of the pre-packaged credentials that I can use. So what I do typically is I create a custom credential type, and then I will, provide the input for the token and username and the URL of the GitLab repository and all those types of things, which is a bit of front-ended work that you need to do. And then in the collection, there's some things that you have to tweak in terms of using the repository. So today we're just all going to work local. I'm going to use Ansible Navigator, which has access to my project in terms of where I'm running, that project and its root directory on my computer. Or if I were using Ansible-playbook command line from, installing the core engine directly, then I would be working locally as well. It's just adding the repo, adds additional, components that we need to manage in that regard. So that'll probably be a follow-on at some point. I did something similar with copying configs. I showed, a couple of different collections on how you can use GitLab or GitHub. And with those, I did create credentials, but I figured that would take too much time right now. So we'll kind of learn how to use the collection, and then we can circle back around on how to, and then, at some point adding Git on top of that. There's another scenario too that you may have, and that is some people will use AAP controller, but with the instead of using Git repositories for the project, it's just the local file system. So if you do that, then what you're doing is you're going into var lib AWX projects and creating a folder in there, and then you still have an EE, but then you can write into that folder. So that one is more like the local scenario as well. It just needs the proper file permissions for the AWX user, and then that's how you would kind of use AAP the way that it used to work in Tower. So there's that scenario as well. But for our intents and purposes today of learning it, then the Navigator is kind of like the first step, or kind of the easiest way to kind of have an EE, but not too much complexity. So having said that, and again, if a lot of this stuff is new to you, we're going to step back through all those, and I'll unpack each one a little bit clearer. In terms of what we're going to connect to, I have 4 routers. So 2 of the routers have BGP, and this is the same topology if you're familiar with any of the network automation workshops that we run at Red Hat. This is kind of like our stock topology that we use for those workshops. And this is the one that we would use for the multi-vendor. So Cisco is a BGP router, and it pairs with an Arista router. And then it has a Juniper router hanging off of it with OSPF. And then also the Arista router has a second Arista router hanging off of it with OSPF. So really, there's no end-to-end connectivity unless your BGP is running. And we'll go in and we'll make some changes. So I've actually removed some of the configs, and we're going to add some configs back in terms of network prefixes. And we'll remove some networks as well. So we'll have the scenario of, adding new configuration where we merge those configs. So we would not overwrite any of the existing configurations. And then the second scenario is like a replace scenario where we are intending on removing configurations that shouldn't be there based off of what our intended configuration is. So that's sort of like the next step into like configuration drift management for the BGP side of things. So we'll take a look at that in that regard. But we're not going to get into anything complex in terms of BGP. So that's something I can circle back with as well, where we can go a little bit deeper, into setting up, prepending paths and, that kind of stuff, and then, direct traffic in, in those types of things. But I'll probably need a better topology than this. So that would allude to using the CML sandbox from Cisco where I can change things. So this one is just meant to be, you have a neighbor or you don't have a neighbor and you're sending networks or not sending networks. So in terms of the resource modules, each one of those vendors has 2 resource modules that are important for us today. The first resource module is the BGP Global. So that's where we would establish, like our autonomous system number and just like the high level configuration for BGP in each one of these boxes or those two boxes that have BGP. So for the iOS and the EOS for the Arista and the iOS for the Cisco. And then the second set of resource modules is the address family. So that's where it could be IP version 4 or IP version 6, and it's very specific commands in terms of configuring the neighbors. And then in those neighbor peers, which networks do we want to advertise? So that's kind of like where most of our changes will be made there. But we could make changes globally as well, and we'll walk through what that would look like. And then for Juniper, I do have the links here as well, but I didn't have time to try to set up like peering between all these routers, so we're not really touching the Juniper router this time around. But to give you an idea of what this looks like and why it's important, we'll go ahead and take a look into some of these links. So this is the one for iOS for the global BGP. And what's really cool about this is that the main parameter in these resource modules is config, and it's a dictionary. So the reason why I really like resource modules when you get into the structured data component of it is that if you were to use some of the other alternative methods for building these configurations, and there's a couple different approaches that you could use. One approach could be using, in this case, since we're talking about iOS, could be the iOS config module, and then there's two different ways in that module or two different types of parameters that we could use to configure the actual device. The first way, or typically the most common way, would be using the source SRC parameter to point to a Jinja 2 template. But the challenge there is we would need to really know what we want to configure in BGP, very specific to the syntax. So that means that I would, in this particular case, and especially if we had all of these routers paired together, I would need to know the syntax for Cisco, for Juniper, and for Arista. And if any of that syntax was wrong, then my templates would fail when we, iterate through them to build a configuration. So that was kind of like the old way or the old approach of doing things, but it's very fast. So with templates, we're pushing that data into the devices that are listed in our inventory. So in this case, and in the inventory, and I'll walk through and show it to you here in a moment. We have the three groups. We have Cisco, Juniper, and Arista, and we could iterate through those hosts and build three separate templates, and that would work. But again, that would be a lot of heavy lifting, or we would need to have more lower level understanding of how BGP works for those devices. And that's one way that we could approach the automation. The second way is, and it's a little bit easier because it's not completely abstracted, but a little, sort of abstracted, is we could use under the config module, we could use the lines. And the lines parameter allows us to include lines of configurations, although we do still need the syntax, but then we can use like the parent parameter if we need to go into a lower level or like a nested configuration. So like everything at the lines level is like when you go into config T, like in Cisco, it would be at that level. But if you go into interface or into the router, like for specific BGP commands, then you would go like a layer underneath that. So you would have the parent. And then a B4 parameter would allow you to like remove configurations before you add a configuration. So not much different than needing to know, syntax in terms of like the Jinja 2 templates, but it's good for like one-off configs where maybe you only need to change, one small piece of the configuration. So those work okay, but they're not really good for configuring the entire box in its entirety because each one of those lines, it iterates through and it's very slow. So you'll see that as you connect to a device and you use, the config module and lines, then you're going to see each one of those iterate, very slowly through those. So it's not, preferred approach. It's more of like a one-off type of thing. And then the third option, and the option that I lead with, is the resource modules, because it works directly with data, and that structured data is pushed into the device, right? So it's very quick, and there's no need to like loop or iterate through, because in that data structure here we have a dictionary. So instead of having to like use the loop or with items, and then that actually adds even more of a penalty in terms of how long it takes to iterate through and build that configuration. This is much quicker because this is just data that is effectively converted to the command lines that are sent as serialized data directly to that device, and that happens very quickly. So it's not attacking it one line at a time. So with that being said, what I can do is I can attack everything from the config dictionary. So when you structure your configuration, whether it's in JSON or in YAML format, then once you have it organized with the proper indentation in terms of building a dictionary, and then this is a nested dictionary, and then you have some string commands, and sometimes they're list. If you follow the approach, you can build like a config in its entirety. But if you're not sure like how to do that, and in some cases it's kind of hard to like read through this and follow this all the way down because there's tons of parameters in here, then that's where the resource modules are really great too, because even aside from using the validated content, if I use the resource module with the state of gathered, I can pull in the data and it's already in that format, so I can see what the data structure is, and then I can create like a second playbook that writes that to a file, and then through like a 2 or 3 step process, then I can build a configuration file from an existing brownfield device that I haven't automated previously. But with the validated content, it does all of those things for me, so I don't even have to worry about constructing the playbook for the gathering of the facts for that particular resource module. It does all those things for me. So I think the validated content, like if anything, like that's huge, because it does it regardless of what the vendor is. So I don't even have to get into any of the nuances between the resource modules, between different OS types, and also nuances between vendors. So all this stuff kind of happens automatically. But again, I still like to flip it back to the resource module for building the config, because I like that flexibility. I don't like being locked into exactly doing it the way that they put forth for configuration. And I'll try to unpack that a little bit more. So this was the global configuration. And if you move down to examples, it's just like any other module that we look at. We can see it in practice. And there's tons of parameters. So this is where this one gets kind of hairy if you try to build it completely from scratch if you're not familiar with the data structure. So let me just, there's like so much in here. Let me get down to the examples. So here's the examples. And in the examples, you can always see examples of the different states. So here's merge, where you're adding a config for global BGP. And then you can see, they've constructed it here with the configuration built under config. But what you can do if you have a configuration file, because this is just hard-coded items, you're not going to use these static values. You're just going to have a variable that's going to call the dictionary, right? And then you'll have this structure to define your variables in your configuration file. So that way you really only have the config parameter to worry about when you're building something, and then the state. So down here you have the state of merged. And merged means if it's idempotent, or idempotent, because if you have an existing network prefix as an example, it's not going to change it if it's already there. It's only going to change it if you have it in your config file, or a parameter, a hard-coded parameter like these are, then it'll add it if it's not already in the device configuration. So just to look at one more example of the address family, let me just click on that real quick. And you can see the same thing. It starts at config, which is a dictionary. The other one had dictionary into dictionary. Now we go dictionary into list. So our config file will look like that. And there's not as many parameters, but there's still a lot for this one. So let me scroll down. And you'll see the same thing. It'll start with an example here on how to use that. And the first one is merged. And then replaced. Those are the two that we're going to use, because merge is for adding in a safe way. new network prefixes as an example. And then replace would be like when we want to remove something, we can change our config file. And when it tries to reconcile what's in the config file that we want to push into the device versus what the device actually has, if there's extra config, in this case networks, it'll remove the networks that are not there. So that's a way that we can clean up our config, as opposed to using the state of delete it, because delete it would remove all the networks for that particular address family configuration. So that may not be our intent, but that is one of the other states is we have delete it. Overridden is kind of like deleted. It deletes everything, and then it pushes your config, which I don't really like that, especially with routing protocols, because it will cause you to have to reconverge, and BGP takes a bit longer than OSPF, and other IGPs are much quicker. So that one you probably only want to use it if you're removing like wholesale, removing that whole global config and then cleaning up the address family configs underneath. So here's delete it. And then you have all those other states too. So gathered is important because it pulls in that data structure. So if you're not familiar with what the config looks like in your device that you manually configured, you can see the data structure when you run gathered. So let's go ahead and let me see if there's anything else super important here. Yeah, so we're going to look at merged, replaced, and gathered. And then for the validated content, what I'm running today, I'm running it from the Ansible Navigator. So I created an execution environment that has that validated content already in that container. So you could use my container if you want to check this out. You'll see it in the Git repository that I'll add to this presentation as part of a leave behind, after the presentation. I'll add that link into there so you can see that link. And if you have an Ansible Navigator, you could pull that down and use it from your Ansible Navigator. If you're running Ansible-Playbook from Ansible Core Engine that you've installed locally, then what you would need to do is you have to install the collection locally. So just note that in order to use the network.bgp collection for the validated content, it has a dependency on network base. I covered network base a while ago, a couple sessions ago, and that was like the more generic collection, and it's mainly what we're using to put those files together, to write those files, to create our configurations, and to kind of bootstrap them to make them ready for automation. That one is running kind of behind the scenes, but it needs to be there. So what you would have to do if you're installing it locally is you'd have to go to this one in this link, and we'll just go to this one so you can see the README file. And it has the right here is what you would need to do to install it. So you pull that down from Ansible Galaxy. And if you're using an AAP, then the issue that you'll have is, I think it'll work this way. Like this is like if you have like a base execution environment, and then in your project, you create a requirements.yaml file. You can pull it down this way, and it'll install that collection on top of your EE, your execution environment, but it takes a bit longer than to kick off your playbook because you have to wait for that turnaround time. But if you were to build your EE, I think the only way that it works currently is you would have to use the console from Red Hat, and that would only work for a customer. Like, so if you want to build your own EE, you need that because you the collection to pull it down directly goes through there. So it's a part of the private automation hub. But I think they're changing that, and they're going to make those available or more available outside of that. But for now, or at least the version that I have, you can try it out. But then over time, if you're, there's going to be additional new validated content coming out. That's how you'll get it, is through your subscription, and it'll go, directly into your hub, so you can use it as execution environments in your automation controller. But if you're working locally or with the Navigator, then you can do these things in the meantime, just to learn how to use them and that type of thing. So you'll install this one, and then this is the usage part of it. So what we're going to do is we're going to build our configs using this example playbook, but we're going to build them locally. And locally means it's going to build in our project, and it's going to use this data store for like the temporary directories that it needs, because it's doing some file copying and that kind of stuff. Now, if we were wanting to use the automation controller in a Git repository, then we would have to have a repo already set up, and we would need this information here for the credentials. So the credentials could either be a part of an Ansible Vault file, or it could be a credential or a custom credential rather that I mentioned earlier that you build in your controller. So it's requiring like the token and the URL of the repo that you'd have to create, ahead of time, and then your username and email so that you can log in. So like these are things that require more work, but it does work basically the same. It's just a few more moving parts. So I may circle back to this one, or just with the validated content in general, because pretty much all of them need something like this to work with the repo. So the gathering doesn't require any of that because you're just pulling in the data into memory. When you go out and gather facts, it goes into memory, and then when you use the state of gather, you're gathering facts for that resource module. In this case, the BGP resources. So that goes into memory, so we're not writing files, so we don't have to worry about local directories versus a Git repository. And this is how we pull in that information, especially from like a brownfield. And then once we have that information and prepare our configuration files, or allow this to prepare them for us, then we can start making configuration changes. If you use this one, this is a part of the deploy, which is another one of the roles or an actions that you can use for these roles, but it's very particular. And you can see that even in the local vars here, they're calling out the Ansible_network OS using the fully qualified name for the OS. So normally, like, you could just use iOS or EOS or Junos, but for this role to work properly, you have to have the fully qualified. So they added that in there, even into the playbook, just to remind people that that is one of the requirements. There's also requirements for other collections to be available. So when I was going through this, there was a lot of things where certain collections have some of the same modules, but you have to have the exact ones that they need for this role to work. So for the read-only types of things, it was pretty friendly, but for the write one, there was a lot of stuff that I had to do. So at the end of the day, I was kind of like, it still seems better for me to use the resource modules, so that way I have more flexibility, and I don't have to do it exactly the way that they have it. But over time, maybe they'll make it a little bit more flexible on the writing config side of things. Then it might be a little bit easier to deal with. But it all works. It's just you have to be very careful, and you have to follow all the errors that you may run into. And some of it wasn't quite documented that well. So over time, this is like the first iteration, through the validated content. And I'll create some log some issues and things of stuff that just didn't seem to be too intuitive, to help out there, like to contribute back. So again, like you'll notice, like each one of them has the local and has the repo version of that. So again, we'll go ahead and do a lot of these same things where we can notice a difference between configs using replaced. So it's all kind of the same stuff. It's just this is what is included, directly in the validated content. So with all that being said, I am over here. Let me hide this. I'll pause for a second. Is there any questions before I start running these live? Is everyone okay for now? Tracking okay? I'm just not looking at, let me pop over here. Okay, so all good for now. All right, so I'm just not watching both screens. So I'm on two different browsers, so I may not catch you if you ask a question in the chat. All right, so let me get this back the way it was. All right, so this is my VS Code that you should be seeing on the screen. And I created some playbooks so that I can demonstrate how to use this validated content. So one thing you'll notice here is that I have an inventory folder. That's different. Like normally I wouldn't do that, but this is what they required for the validated content. So they recommended an inventory folder, and then I included my inventory in that folder. So here's my inventory, and I have a Cisco group, an Arista group, and a Juniper group. Now, these are virtual routers that are running in AWS. So for me to connect to them locally, I'm just pointing to an SSH key. So that's why this is here. But when I run this in my controller, I have a credential that I'm using on the controller that has that key. So I just comment these out. So like if I save it into my repo, in order for it to work on my controller, I just comment those out. So this is only because I'm working locally while I have these particular configurations. And you'll also notice that I'm using the fully qualified names for everything up here. And that is because that validated content is very sensitive to that. So you can get away like normally with just network underscore CLI and ILS. So I had to use the full names in order for things to work, using that collection. So just to point that out, if something doesn't work, when you look into error messages, you'll see a lot of those types of things where it's just unable to find something. And 9 times out of 10, it's because you're not using the fully qualified name for whatever it is. So we have these in here, and I have like the normal information that you would expect for each type of device. They all have different connection types and nuances there. Like Juniper, as an example, uses netconf versus the network underscore CLI. So you just have to make sure you have that straight. But once you have everything working, and what I do normally to check that too is just do like a quick, gather facts. So I did, get facts down here. So I'll run that real quick just to make sure everything is still working. It's pretty much the get facts will work the same across the board for across vendors. And if you can't authenticate, then that won't work, obviously. Now, what I forgot to check too before I ran that is I didn't have every device in there. So I think I just had the Arista. So let me look at that one. Yeah, see what I did is I have the Arista and I need to comment out the ones that I want to look at. So I'm not going to waste time going into each one of these because I'm pretty sure the way I have it, if one of these is turned off, they're all turned off. So everything's up and running. So we should be able to connect to it. But you can see how, like in this one, I was just commenting out the different module for the different types of, network facts. So we just hit the Arista one up here. So we'll go ahead and go into the first one. So the first playbook here is to gather the facts, pertaining to BGP. So this, because it's the validated content that we're pointing to, and the reason why I know that is because we're including this role here, network.bgp.run. So this is a role that will allow us to kind of stitch together what normally we would do separately, or we would do it like 3 different ways, right? Because we would have 3 different vendors. We would have to use the BGP global and the address family. And we'd have to use, the specific ones for each one of those vendors. This will figure out what we have, and it'll run it across those vendors. So because of that, I have a group called routers. So if we look into the inventory here, routers is Cisco, Arista, and Juniper. So the cool thing about this validated content for this part of it, for the gathering facts, is I don't have to do anything special here. It'll treat all the vendors the same. So it's abstracted, like another layer of complexity away from what normally I would have to do with each vendor. So to run this one, let me just bring this up real quick. So we'll run this. And if you recall earlier, I mentioned that 2 of the routers are not configured for BGP. So this is smart enough to understand that as well, and it won't error out. So it's only going to pull the ones in that actually have a BGP running. So for router 1 is the Cisco router. These are the networks that currently are in those devices. So, or in router 1, right? So we have these network prefixes. This is its own router ID, loopback 0. But it doesn't have like any of the other loopbacks from any of the other routers or anything like that. So this is all that router 1 has. And you'll see the same thing as we scroll down to the Arista is router 4 here. And this one doesn't have any BGP. Or does it? No, router 2 does. Yeah, router 4 doesn't. So see how it's empty? Gathered is an empty dictionary right here. So it doesn't error out. It just doesn't have anything to populate. But router 2 is the one that has BGP that's Arista. So it has these networks. And it's the same thing. It only has its router ID. It doesn't have the other router IDs. It's not advertising, any of those other networks that are a part of OSPF hanging off of them. It's just the networks that it's advertising between router 1 and router 2. So this is the current state. But at this point, I haven't converted this existing router into configs that I can use for automation. So that's where this persist role is very important, because it'll create those files for me and build them, and it'll do it across the vendors. And again, it understands if they have a BGP configuration or not. So it adds another layer of abstraction that we would typically have to figure out how we want to create that playbook to write those files. It's not a ton of work, but there are nuances, and every time there is nuances, it just adds more complexity. When we run this one, you'll see that it's going to build some folders and files for us. Right there, these two change, router 1 and router 2, and now we have a host vars folder. And then when I go into each one, it's broken it down into the different resource modules. So we have the address family in the global. So global, we have an AS number 65,000. And then when we look at router 2, the Arista router, it's 65,001, right? So each one of them are peered to each other. And then in the family config is where we have the networks. And you'll notice that it's not the exact same data structure. So it handles it for us. Otherwise, I'd have to figure that out if I'm building my configs for these guys, them being, different vendors. So in this one, you can see that it's networks, and you have address, line and mask. And then we just have a list of those. So each one of those networks, and it stops at its own router ID right here. When I go into the Arista, you can see that the mask is a part of the address. So a very small nuance, but that's the exact data. Otherwise, it'll error out when you send it to the device. So it's those types of things that it handles for you that I think is really cool, because it's smart enough to be able to do that. But if I was building this, then I'd have to realize that myself. So so those are two configs, right? So now that they're in there, I could deploy a change. So in this particular playbook, I didn't use the validated content for that one. Deploy, change, replace. This is not deploy new changes, state merged. Oh yeah, that's right. Yeah, so what I did here is this is my stuff. So I created my own roles. So all I'm doing in the playbook here is, now that I know that router 3 and router 4 have no BGP, so instead of connecting to them, I'm just going to connect to router 1 and router 2, and they're BGP peered together. So what I want to do is the state of merged, because if I want to add something new, I don't want to remove any of the existing config, and I don't want to be disruptive to what's already there. So I'll use merged. And then the roles that I created is 2 roles. So I'm using the 2 resource modules that the validated content is, but I'm using them directly. So I have the BGP global and the BGP address family. So to see like the actual playbook, I've created a role. So I go into roles, and then in roles, I've got the address family one and the BGP global. So each one of them has a main file. Let me start with the global one. And you can see here, I did what you would typically do, is create conditions, right? So I have Cisco and Arista. And the reason why I do that is because their configurations obviously are different, but also they're not the exact same data structure and things like that. So I need to separate them and use their specific collection, right? So for Cisco, it's Cisco IOS, and for Arista, it's Arista EOS. And they both have the same resource modules, but they are different. And Juniper has its own. And because I'm not running Juniper, I still wanted to have it in here, because if I bring up a Juniper router, then if that's a part of my inventory, and if I point to a Juniper group or a host that's in a Juniper group, then I can run this particular one. So if that host is in this group Juniper, then it'll run this. So the only line that I have to have is config, because remember, it'll take that whole dictionary. So I don't have to use loops or any of that stuff. I'm just going to read in that entire dictionary, or the dictionary in terms of what we've pulled in from the current device. So right now, like if I ran this right now, it's just going to try to run against a config that's already there. But because it's idempotent, then it's not going to change anything. You'll just get OKs. But if I change it, then you'll see it change. Or if I run it in check mode, you'll see it change, but it's not really going to apply the configuration. So I have all those same options like I normally would when I run playbooks. So I'll run it real quick as what it is. Current config. We pull down from the validated content over here. And it should be fine and just run it. So it just ran it and all we have is OKs, right? Because we didn't change the configuration. So what we could do now, just to show how it works, is I'll go into the address family and then I'll add a line. And router 1 is connected to router 3. I'll save that. And then I go into router 2, the Arista router 2. It is connected to router 4. All right, so I saved my configuration here. The Ansible knows to read this in because it's host vars. So if you create group vars or host vars, that is one of the locations that Ansible will automatically look to determine what the variable is, right? So it'll populate those variables based off of these configurations. So this is just one of the locations. So that's how it'll find it. So if I run this again, we should see it change and add those networks. See, this one changed for iOS, and then EOS changed. So instead of going into my artifacts to see like lower level if it actually worked, what I can do is just run my gathered again, which is the number 1 book. The cool thing is with playbooks and using these modules, I really don't even have to touch the router at all. See everything. All right, so we want to see router 1. Scroll through router 1 here, right? And here's what we added. And then in router 2, we added this network. All right, so they're there now. Now, the one thing that we haven't done is we haven't tried to change or remove anything. So that's the other thing that may happen. Like at some point, you need to remove a network that's not there. So that's where replace can be used. So replace is effectively the same thing. It's just we're changing the state. So in my role here, we'll go and look at how it's set up. I made that a variable state. So in my playbook that we ran here, deploy, the state is merged. So if we go in and we want to remove a configuration, pull something out, and we don't want to delete the entire configuration, we can use replace that state. So that's what we'll use this time. But before I do that, I want to change the config. So I'm going to remove this network. File C, or just Control S. And then in this one, remove this network. I guess I can clean that up too. Cut. File save. All right, so this should actually remove it because it's going to look at the config file and see that, you know, when it compares the config file with what's running in the running config of those devices, it'll say, okay, here's a network that's in that device that's not in my configuration file, so replace it, remove it. So let me go ahead and run that one real quick. You could use overwrite, but that's going to like delete the whole thing and then replace it, which is more disruptive. So the one that I want to run is number 4. We should see a change as well. Change the Cisco router and then change the Arista router. And then again, here to gather, and I'll see what's actually in there. Right, so this is the Arista router 2. We removed the 4.4, and then up in the Cisco, we removed the 2.2, so we can just confirm that those are there. So those are kind of like the basic, lifecycle management of networks or network prefixes in BGP. And then the last thing was just a health check. I started this, but I didn't have time to really make it too fancy. But it was another example of a difference between Cisco and Arista. So when I was doing this, I noticed that I was trying to use this generic netcommon CLI underscore command, because if there's a common command that works between vendors, then this is like a generic module and it'll work. But the problem that I realized is that Juniper and Cisco have a show BGP summary command, but Arista doesn't. So its closest command that's equivalent to that would be show BGP statistics. So it didn't kind of work out the way that I was planning on. So I created a condition because that's different. But you can do a lot more with this. You can use the validate collection with or utils collection with the validate module, and you could do like checks, because I could do a show command and parse it out, and then make that like a pass or fail criteria. So obviously, like with BGP, you want it to be established, those types of things. But I didn't really get that far. Here, I just did like a quick show, just to make sure that everything's running still. So for this one, it just shows that it was a little bit different for each vendor, so it didn't, wasn't that great anyway. Let me actually, I don't want to mess that up. So we can see here our neighbor, right? So this first one is the router 1 is the Cisco. Its neighbor, this .2, is the Arista router. And you know that it's up when you see the timer up down here. It's up. When it's not up, you'll see either established or like whatever state it's in. So you'll see that state change here. So it's like one way of tracking that your neighbor's there, and also all the other, the top level BGP information. And then this is like the equivalent, but not as much information on the Arista side. So we can see that we're established, with this is our router ID for 65,001, and it's established to the neighbor. It doesn't say what the neighbor is, but the neighbor is this. So this one's kind of cheesy. I didn't really get too far on this one. I need to make something a little bit fancier in this regard. But just a quick check to make sure that like all those changes that we made, we didn't knock down BGP. Everything is still functioning. So that's what I had like for this basic, or this first round of BGP configs. But let me go back to the other screen, and before I cut this recording off for this front part of this session, does anybody have any questions or any stuff particular with BGP you'd like to see the next time when I do like a more advanced BGP session? And I'm sorry for like the beginning. Probably a lot of people couldn't get on because I had the meeting all screwed up. Okay, so I'm going to go ahead and shut this recording down.